This video is about quantum tunneling. Earlier, we learned about the wave function of a particle. According to quantum mechanics, this wave function tells us that there is a finite probability of the particle being everywhere in the universe at the same time. Of course, in most places, this probability is extremely small. Nevertheless, it is not zero. This means, for example, that when an electron is in the ground state of a hydrogen atom, it might, in some cases, escape the attraction of the nucleus with less than 13.6 electron volts of energy. As we learned in topic 7, according to classical physics, an electron needs to receive 13.6 electron volts of energy in order to escape from the ground state of a hydrogen atom. However, this is not what happens during the process of quantum tunneling. Instead, here is what takes place. The electron borrows energy from its environment. It passes, or as we usually say, it tunnels through the barrier, and then pays back the energy to its environment. We can say that in our example above, the barrier that the electron tunnels through is the 13.6 electron volt energy level that the electron does not possess. The process we described above is in agreement with the uncertainty principle and is called quantum tunneling. The factors that affect quantum tunneling are the energy of the particle, the width of the barrier, and the height of the barrier. Higher energy and the thinner and lower barrier all lead to a higher tunneling probability. An example of quantum tunneling is the low-temperature fusion that takes place in the Sun. We can also explain quantum tunneling by using a simplified probability wave function diagram. The purple rectangle represents the barrier. As you can see, the wave function stretches outside the barrier and shows that there is an extremely small, finite probability that the particle will tunnel through the barrier. This completes our discussion of quantum tunneling and wraps up the final video of subtopic 12.1. In the first video of subtopic 12.2, we'll learn about Rutherford scattering.